Okay, so yeah, it's about time to start, so let's start. Welcome y'all. I'm Rafael Fernandes, and I'm going to be talking a bit about service workers and the things you can do about service workers and some cool stuff with them. Yeah, first of all, I had to use the template, so this is my using the template, and thanks to Microsoft for letting me talk here. It's kind of cool. So, who am I? I'm Rafael. That's my Twitter handle. Any question you want, just send it to me on something on Twitter. I'll respond as soon as I can. That's my website. This is a lie. My website is live right now. It's been live for 2 weeks, I think. It's still pretty empty, so yeah, take it as it is. With time, I'll have to improve it a little bit. And this is my GitHub handle. So if you guys want to check out anything I have on GitHub, just feel free, clone, fork, whatever you want. It's MIT licensed, so feel free. This is where I live. I'm living in Amsterdam. Although I'm Portuguese, born and bred close to Lisbon, I'm actually living in Amsterdam. And currently I'm working for a consultancy company called Non-Dutch. Yeah, it's a Dutch company called Non-Dutch. We're all expats, that's why the name. And currently my client is Rabobank. The second, yeah, it's the name, it's not a joke, it's really the name of it. Not kidding. It's I think the second biggest bank in the Netherlands, and I'm working on their mobile app. So when people check transactions and that kind of thing, that's where my code kicks in. And yeah, I'm working in Utrecht Centraal in the towers, so that's totally me working overtime and that kind of thing. So the agenda for today, I want to talk about what are service workers, a bit of the philosophy behind service workers and kind of the mentality you should have when using service workers in your apps. Then talk about service worker lifecycle, including the update parts, and then some few extras, mostly because I need to put in some more content there that could be useful for you guys. So yeah. So first of all, show of hands. Does anyone here know what a service worker is and what does it do? Okay. Well, cool, because that way only 2 people will be bored by today. The rest of them hopefully will learn something cool. So what is a service worker? Service worker, I don't know, do you guys also know what web workers are? Okay, so service worker is kind of a specialized type of web worker. It's basically, the browser creates a different thread that will act concurrently to the main UI thread. Because of that, the service worker has no DOM access. So whatever communication between service worker and the main UI thread should be kind of like web worker via post message, or then through the intercepts that service worker is able to do, which I'll talk about just in a little bit. What is the service worker for? Service worker is a new layer of cache that you have, which is in between your JavaScript and your browser cache. This little piece of, like, let's call it middleware, is what's going to make you able to give partial functionality or full-fledged functionality depending on how your website is built, even when the user is offline. So you do have a lot of control over it. You can intercept every request that the user makes with your app and return whatever you want. So theoretically, if I'm looking for index1.html, and if the user is offline and you want to give them something different, like a 404 or something, you can have control over that and choose whatever you want, because it's all written in JavaScript. It's all plain JavaScript. There's nothing more to it. So besides the caching, it also supports versioning. That means that you can update your service worker during its normal lifecycle. And this is exceptionally useful for, obviously, when the user is offline, because it's nice to have something there even when you have no internet, but also in scenarios of really slow connectivity, or as I like to call it, Li-Fi. Usually like when you're in an airport and the internet connection to the router of the airport is pretty good, but to the rest of the world ain't that good. That's where this could be, for example, very useful, but you also have to think about countries like, let's say, for example, a country that has low internet, obviously low internet connection, where people use 2G networks, like India in a lot of areas have still 2G networks. This could be very useful for an app that's working there. So what was the typical thing that used to happen? You have a web page. Your web page wants, I don't know, 10 or 20 requests. 10 requests. 20 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 requests. j1.js file, you ask the server responds, page gets it, parses it, does whatever it wants with it. That's the typical thing. With the service worker, you can actually have something even if you're offline. So that means when the j1.js file is asked for, you can actually turn it even if there's no communication with the server at all. And how does this work? So now you have your typical web page. Your web page makes a request. The service worker is able to intercept these requests, and then you can talk to the server, and the service worker gets the response, and then caches it, and responds to the web page. It is also possible to do that concurrently, so the user does not wait for anything. So let's say, for example, I'm asking again for the j2.js, because it's something that happens sort of like reactively or something. And the service worker said, hey, I don't have this on my cache. So what I'm going to do is I'm going to clone this request, make the original request go to the server, respond to the client first, and then make my clone request happen and keep it on my cache after. So that the next time the user wants, when he like reloads the page or whatever, wants to get the j2.js file, it's already there in the cache. So you can actually proactively cache things per demand, which is extremely useful because you can actually work with scenarios that you originally did not predict, as long as there's inside your scope. Meaning that in time, if possible, for all, and the most obvious things are your assets, your HTMLs, your PNGs, your images, JavaScript, CSS files, you can cut off all communication with the server altogether unless there's actually an update you really want to do, which not only is a lot faster to the user, it also cuts a lot of bandwidth for your server. That's a huge gain you get there, because there's a lot of the downside of server maintenance you don't have to do anymore because you just don't have that many requests. So you only get requests for, I don't know, you want to do a post or whatever, yeah, that sure needs the server, but the rest of them, not really. And that's really, really useful. So now that you know all this, that means you have to think differently. You have to think offline first, because you have to think firstly how you're going to work if you're offline, because you have to assume that ideally you have all the things you need to make your app work. So that means you need to get as much things as you can cached. I will talk on how to do that and when to do that. And like I said already, getting cached information is better than showing nothing. I mean, it's better for the user to see a non-up-to-date site. Let's say, for example, Facebook. When you're offline, because of reasons, and you go on Facebook, there's a lot of stuff cached. You're not getting the new requests. Same with Twitter. It's better to show something to the user and provide a meaningful user experience for something than nothing. And that means your user, I'm not going to say happy, but happier, because users are, you know, especially, when you're online, offline, Li-Fi, ideally in all possible scenarios. So, first of all, you have to install a service worker. How do you know if service worker is available? Simple as this. You just check if a service worker is available on your navigator. So make sure the browser is responding to the service worker API. And you should also make sure that cache exists. And here in this example, I have the prototype at all because it's the cache function that allows you to cache more than one file. So you can actually send an array of files. This by default, I want to cache my index.html, my all.css, my blog post something.css, and my angular.js or whatever. Or you can also use this page, pretty useful. Jake Archibald is one of the big guys at YouTube that is, well, he designed most of what I'm talking about, actually. He's one of the main guys behind it. So yeah, this nifty little page you can use to check if the browser is already responding to the API properly. So I would advise you to use that in the future. So now you know the service worker is available. Yay, you can use it. How can I use it? First, I have to register it. It is this simple. It's not a lot of code. Because service workers work at sync by default, you're always going to be working with promises. I'm assuming all of you know what a promise in JavaScript is. I'm not going to talk about how they work, but it's basically a way to work asynchronously, a little bit better to avoid the callback hell that we used to have in JavaScript a few years ago. When you register a service worker, of course, you have to tell what file it is and what's the scope. And then when the promise fulfills, service worker installed, do whatever you want with it. Or when it's rejected, time to cry in a corner because it didn't work. Now, the thing that I talked about, the scope. Be careful with the scope. Because if you register 2 different service workers in the exact same scope, you have to remember that the browser used the scope as like a sort of an ID. So I could do exact same code, and instead of serviceworker.js, I do serviceworker1.js. The serviceworker1 that happens, the register process happens after this one will completely override this one, meaning this one will be dumped, and the new one will be running. There's still a few things in the specs that aren't 100% decided upon. For example, at least from last week when I tried it on, an example of, let's say, you have, this is the main scope that works with all the app, but I could have like /blog /video /something, so I could possibly have multiple service workers running concurrently, each service worker with a different thing, which would be useful for, let's say, a big enterprise app, because you have different teams working with different parts of your website or web app. But if you do this, and then you do that more specific service worker, this one will still overtake that. As in, the more specific will not get a request, this one will. So be careful with your scope. Okay, so regarding the service worker lifecycle. The first time you're using the service worker, you're doing just the install, and the service worker goes automatically to active. So this time, what is the install event? The install event happens whenever the first line of code in your service worker.js file starts executing. And this is the ideal time for you guys to start caching your stuff. Because remember, you're in a different thread. So even if you're doing something that's kind of, well, of course, try to avoid doing something heavy, because you can be working with a low-end device on like an old phone or something, like my phone. So please don't do that kind of thing. But this is the time when you can do stuff. It's a different thread, so don't be afraid of blocking the UI thread. And now it's time to cache stuff. Because then eventually when the service worker kicks in and gets active, you already have everything cached, and the user ideally will not have to wait for anything, because everything is already there. Yeah, and it is possible, so then you do event.waitUntil when you're inside the install event to make sure that the event waits until everything is cached, because since this is sync, you have to make sure that that happens. Otherwise, the user could have the service worker working when all the caching process is still not done, and then the service worker could be, even though it's a small block, it's still like a small bottleneck you have there, so try to avoid that. Moving on. This is how you detect the install event, also extremely complex code. Keep in mind that the self word here is a reserved word that works with on the inside the service worker, and it's a reference for the service worker itself. So you don't have to actually do self.add event listener. I do this even at work to make it more legible. So when I'm doing this, then okay, this is the service worker that's working with himself. And yeah, you can see here the event.waitUntil update cache. Update cache is a function that we will do all the caching stuff, returns a promise, which is fulfilled when all the cache is done. Now, when the service worker is active, meaning that the install process is over and now you're actually starting to have it running, that means the service worker has taken control of the request, its client, the browser. The service worker, also I forgot to tell you that, is a service. So it will be running even though the browser could be offline. Oh, not offline, sorry. The browser could be off, as in turned off, closed, whatever. Meaning, actually, if you guys went and checked how many service workers you have on your laptops or phones right now, you probably already have a lot of them. Google, The Guardian, I don't even know any example right now, but there's already multiple sites that are using service workers. With this, it means that you can now take control and intercept requests. With that, you can return what's in cache. So here is like the main event, the main life cycle thingy where the service worker works in. And like I said, you can proactively cache stuff. So if it's not in your cache, you can then do the cloning thing, put on your cache, return to the user, etc. The service worker can also handle push and sync events, which is pretty useful, like I said, because it's a service when the browser is out. And let's say you were talking about WhatsApp or Facebook or whatever. Some event happens, I got a message, a text or whatever. With a PWA that works with a service worker, I can just get an event and I don't have to actually install the app itself. Actually, if you guys go to Twitter on your phone, the mobile page for Twitter is already a progressive web app that's using service workers to do that right now. It's in production. Although it's only started last week, I think. So it's still kind of new for them. Okay. And also, yeah, this is when you know you're on the active life cycle. Also extremely complicated. Oh, yeah, this. I kind of forgot about that. It's a good idea when your service worker gets active, because each cache has a cache name. It's like how you identify different caches, to delete old caches. Of course, do not delete all caches, because you might delete things you don't want to, but this will be the ideal time for you to do that. Okay, so now you know how to install a service worker, how a service worker works, kinda, but now, how do I update my service worker? Let's say, for example, John made a bug, and the service worker is screwing everybody's life because by default it's always returning a 404 file. You need to fix that right away. So how do you do that? Okay, so now you have one more event life cycle, which is the waiting period. So this works exactly the same as the previous one, but you have the waiting in the middle. And that means when your install happens, your version has changed, because you can use a service worker versioning system to actually force this to happen. And that means you can now, the old service worker that's still buggy, screw John, is still running, but your new service worker is still in a different thread, working, actively caching new stuff. When this one hasn't been deleted, that when this one activates, meaning this one is kicked out and is now working, that means the waiting period is over, which is this one here. One thing I have to take into account, refreshing sometimes is not enough, as in it depends on the browser implementation how things are done. What I usually do when developing is the full refresh, as in, well, because I'm using a Mac, Command-Shift-R, but with Windows, Command-Shift-R, no, Control-Shift-R, right? Or Linux or whatever. Probably is that. Okay, thanks. And then, yeah. Yeah, so when the new service worker gets active, that means the old one is gone, the new one is cool. John's work probably might have not been saved. Sorry, John. But yeah, and with this, that means you can now delete the old caches like I had in my previous example, because maybe the old caches were wrong, or like because your logic on your service worker, your business logic has changed, something like that. You can also, on service workers, much like web workers on the main UI thread, can use IndexedDB. So you can actually use this moment to maybe migrate your IndexedDB to a new one, because IndexedDB allows it. I'll talk a little bit about IndexedDB in a little bit. So yeah, that happens. Now, why did I talk about John and his screwed up code? It's because in case of an emergency like that, it is possible for you to order a service worker to skip the waiting phase and take charge or take control and run to the active state ASAP. Because, yeah, John screwed up. It happens. I'm sorry, John. It happens. But yeah, no, but this is a good example because some sort of emergency that could happen. You never know, like, things that you cannot foresee happen all the time. And this is a good way of using that. So this is just how do you do that. You just do self, which is a reference to your own context, escape waiting, and you go to the active state. Okay, so I've talked about most of the basic service worker stuff, so let's go for some extras. This is a pretty nifty little thing. You can, on your UI thread, force a service worker to update. So let's say, for example, this unlocks you a huge, like super powerful feature. Let's say, for example, you got your server connected to your web page via WebSockets or server-sent events or any other framework that does that kind of thing, sending events from the server to the client that you're using. And let's say it's time to finally update something because your page has evolved, your business logic has evolved a little bit. That means with this, the user can have its own old service worker updated, new cache being taken care of, old cache being removed, while he's still online, without him ever noticing and feeling a very small amount of lag, because it's all different threads. So you can actually have a business that runs and updates itself, and the user doesn't know. So next time he refreshes or tries to get that asset, let's say, for example, with Facebook. Facebook, I think last year changed the logo a little bit, like the kerning of the app or something like that, and like a few icons and stuff. With a service worker doing that, I don't even have to get those assets myself. I don't have to do refresh. The service worker does that for me, and the next time I do refresh, it's already there. I don't have to wait. It's really powerful. So, we're getting closer to the end. Sorry for blocking this part of the screen. It's not that useful. It's more for me than for you. So a few more extras. I've talked about the service worker lifecycles event. And I don't want to get too boring because I know this has already been a bit too long. But if you want to, you can actually know when your service worker is that in your client. You just have to, go for the state change event, and then with that you can use a service worker reference to know what type it is, because maybe, and to be honest, I right now out of the top of my head I cannot remember any kind of example that's useful with it, but it probably is. The world is a big and wide thing, and I'm a very small thing compared to it. So this is how you do it, in case it's useful for you in the future. Okay, so another really cool little thing. This is not service worker related, but this is useful. You can know when your browser is online or offline, isn't connected to some network or disconnected from any network with this. That means with knowing this, you can actually act and tell the user when he's offline. Let's say, for example, because he got into a plane and he forgot to turn off his 3G. You can say, hey, you're offline, but don't worry, I gotcha. I'm going to give you some partial functionality because you're offline, but at least the user is informed. He knows what's happening. Actually, on my little demo that I'll show you in just a little bit, I have that happening. And that's good because your user is still able to see your app, it's still able to interact with it, but he knows he's on a tough connection situation, so he knows what to expect. You're not going to get the refresh and doesn't work, or send and doesn't send, and the user the fuck is this? No, it actually works, and the user is informed. Okay, this is a really cool feature that is still in an earlier stage in what I've talked about, which is readable streams. As you guys know, browsers have been working with streams for a long ass time. Like when you get a huge HTML, your browser by default is able to parse that HTML as it gets, because the page is being constructed as the browser gets that. Now the thing is, and this has been a problem with some of the single page applications, you need to get your HTML, your CSS, and your JavaScript, all those bundles together, and then maybe after 2 seconds, the user gets all the thing. And with this, you can actually stream that to the user. Now, a cool thing is if you're in a situation that you have to return a lot of DOM elements or a lot of HTML, you can actually stream the HTML, and the user gets chunks of it and parses the service worker sends that to the main thread, and the main thread starts parsing the HTML, so you can actually see the page being built instead of waiting for 2 seconds of, I don't know, some loading screen, and then poof, it's there. But also you can use, let's say, for example, I use the example of India. I will go that because a lot of part of India is still using 2G networks. Let's say, for example, I'm I don't know, a bank, because I work right now at Rabobank. So I'm a bank in India, and my client is somewhere in the city of middle somewhere that has really slow internet connection, and he wants to check his own his transactions on his phone. He starts doing the pull and to refresh or scrolling down to check more and all the transactions. And what a lot of things do, and let's say for simplicity's sake, I'm going to send 1,000 transactions in one go. The user has to wait in a 2G connection for a chunk of JSON, assuming that I'm going to send you JSON, to get all that. So that means I do scroll down and then wait, I don't know, 5 seconds. That's a lot. With this, you can actually, instead of doing a big JSON file, you can do, like, for example, every transaction in one small JSON file, stream them, and then the user, as soon as he gets, because, I don't know, he has React or Inferno.js or whatever, he can start rendering things as he gets them. Why should I wait for transaction number 999 when I can just read transaction number 1 because it's already there? This is a huge thing that you guys should use that in the future. It will be very useful. Now, IndexedDB, the thing I talked about a little while ago, it's a database in your browser. You can actually use this to store stuff. It is sort of publicly available, so do not store business logic sensitive stuff or private stuff for your app. But you can actually store a lot of things there that could make sense for the user. Why not? Why do you have to go to the server to ask for this? My little demo app that I'm doing is completely just, has no server at all, and what I'm doing is it's like a to-do list. And every time you do add a to-do or remove a to-do, I just put it on the IndexedDB and move it to the IndexedDB. And then when the user refreshes, it's there. You don't have to, well, you have to wait for the IndexedDB to return it, of course, but that's kind of pretty fast. And you can actually, so you can do all the CRUD operations that you used to do with a normal database. You can set a data schema, and you can set indexes, and so you can actually do fast queries. So if you actually have a sort of complex-ish data structure, you can actually work with it to make it faster, which is really, really cool. It also, like the service worker supports upgrades, but that's a whole different talk. I'm not going to talk about it today. And also works offline. That's also the main reason why I talked about it. And last but not least, service workers are not the only thing that is able to access the cache. And this means, and this is actually something I want to do in my websites. It's a blog, so this is something, when I get the time to it, I'll do it. If the user clicks a button, you can actually save something for him to use offline. So ideally, in my blog, what I'm going to do is, user reads something and is like, this is really cool, but this guy's kind of boring, this is kind of long. I don't feel like reading this right now, I will read it later when I'm on the plane or when I'm traveling in the Safari or whatever. Then you just click to save to offline. You save whatever you want to save. And this is actually the cache thing function. You pass an array of URLs to cache, and you just cache them like this. It returns a promise. When the promise is fulfilled, things are in your cache. Up you go, it's available. Okay, yeah, a bit of shameless self-promotion because I'm pretty much in the end. I did a little app, a little example, the thing I talked about, the to-do lists. It works on your phone. This is on my GitHub page for now. Eventually I'll take it up, but probably in a few months. So if any one of you just go on GitHub and check it out. And this is like a little to-do list. You just remove whatever is done and whatever is available. And if you want to do something, you add it here. If not, okay. And also pretty cool is that you can do this. Turn Wi-Fi off. Hey, you're offline. And I got a little red thing, so the user knows offline. That means it's supposed to expect lower functionality. Because let's say, for example, this would be stored in the server. I'm not able to communicate with the server anymore. But when it gets offline, when it gets online, just like I said a little bit ago, user gets informed, hey, you're online. You can start working again. Yeah. This is on my GitHub. It's using IndexedDB. It's using web workers that are using the IndexedDB. It's using service workers. It's full of comments. It's full of console.logs with different colors. So it's easier to read and understand. So if you guys feel interested in learning a little bit more about it and experimenting at home, fork it, clone it, read it, experiment, learn. Because I am not smarter than any of you. I just took the chance of talking about this and doing this at home. So try it out. You're probably smarter than me. I'm not that smart, so just do it. Don't feel afraid of doing it. The community is wide. The community is big. You're going to get a lot of support very easily. There's a lot of information everywhere. Talk to me on Twitter. I'll respond happily to any questions I know I can answer. Or if I don't, I'll try to get some information that can maybe help you. And use that to improve and hopefully bring service workers as a norm for everybody so you can use it. And so people around the world, ideally, are able to be happy with it. And yeah, that's the end of it. If anyone has any questions, feel free. And it is possible via the browser. Are you talking about for production or for the developer? You can. It is possible to unregister service worker via code, which is very similar to the service worker register thingy. It's just unregister. I don't remember the API on the top of my head, but it is very similar. You can put a new service worker with the exact same scope that will overtake that one, but then that means you're not deleting that. You're replacing that with another one. Of course, you can replace a service worker with an empty service worker that doesn't know anything, but it's still an overhead. So you might as well just have an event that is able to catch that and just unregister the service worker, and maybe in the future when things are okay, register the new one. For the developer, what y'all can do is you'll here inspect. Can you guys read this, or should I increase the? It's better? Okay, so if you guys go here on application, yeah, service workers. You go here and here. This is my service worker that's running right now. And if I want to force an update, just do here. If I want to force stick events, I can also go here, the push, and also the unregister, meaning that service worker then dies. And then if I do a normal refresh, it's going to get all the stuff again. Also, as you can see, all the colored console logs, so you guys can understand this when you're running locally at home. It's right over there. Did I respond correctly? Okay, cool. Any other questions? Yes. Not 100% tied, but it's yeah, cache storage. It's what I think it's called. Yeah, it's the new layer of cache that sort of was created in sync with the service worker. Although it is available, like I said, to the main UI thread. That is possible to use. But yeah, it's a new API thing that came along with the service workers for you to use. Any other questions, or was I really good at talking? All right, well, then if that is all, then if no other questions, thank you for coming and for listening to my rants. And if there are any other questions that eventually pop up, feel free to talk to me over there in the corridor in the streets, or on Twitter, or find me on LinkedIn, or I don't know, just do whatever you want. I'll be available to talk. I'll always try to respond to anything. Thanks.